Good morning or good evening to all, and welcome to the Data-Driven Community virtual meeting. A few words about the Data-Driven Community. As you can notice in our website, we are managing two branches of activities. If you will scroll down the page, you can see the upcoming events. On the right side of the page, you can notice the upcoming weekly meetings of the Cloud Data-Driven User Group, like today. On the left side, the second branch of activity we run is an annual conference called Future Data-Driven Summit. Don't delay getting your early registration. Do it now, do it today. Early registration can get you to a special list. Update information will be sent by email, obviously, to those who are registered. I assume everyone familiar with the phrase for the community, by the community. A lot of time people forget about the second part of the sentence. This conference is for the community. It is organized and run totally voluntarily with a team of volunteers from the community. Today it's time for the second part of the phrase as well. I need 30 seconds of your time to help us test something. So I have just finished to develop a new registration application for the Future Data-Driven Summit. I asked everyone, please use this link, use the URL, the QR, sorry. I will put the link in the chat as well. Go there, do not submit the form yet. Again, fill the form until I explain what we are going to do. Do not submit. I want everyone to submit it at the same time for the sake of this test. So let me put the link in the chat. One second, let me open the chat. Okay. You have the link in the chat. Let's continue to explain what we are going to do. So, what you need to do basically is to fill this form. We are going to test it behind the skin. It's a totally new application based on logic apps and a few more features. Do not send it, do not submit yet. Fill it, I will do it with you. I give you the time, I speak to give you the time to do it, and please do it, everyone. Torsten, please do it as well. Jen, everyone that here, we need to check that it is actually working. I tested it by myself, but we need a few more tests before we actually release this information to the public. If you do not want to register to the event, I don't know why, if you are crazy and you don't really want to be part of the biggest virtual event of the year. So in the promo code, write the word test. This way I will be able to remove all of those test registration. Otherwise, assuming that this is a form will work and you will get an email, then this will be your actual registration for the summit. So again, fill the information, make sure that you are using the right email, because there is a second step. You should get an email with a link. You will need to click the link, and only after you click the link, then your registration will be completed. So remember, don't submit yet. I will count from 5 to 1 and ask you to click. I hope that you are all ready. I spent a lot of time to give you the chance to fill it. The only thing that you must fill, it's you must accept the code of conduct, first name, last name, and email. All the rest of the information, it's public information that you can fill if you want, but it's not required. Okay, Torsten, are you ready? Did you fill the form yourself?
For sure.
Okay, so let me fill it fast as well, and then I will ask everyone to submit. So I'm doing it live, and I will fill it just like you. I will use my community email. I'm from Israel, consultant, Twitter. I don't have time to find my Twitter and Facebook, so I will just put this, but I recommend to use the link if you have the time. Okay, please be ready. Don't forget to use test in the promo code so we will know if you don't want to register. It's really crazy that someone will not want, but I give you this option and I will count from 5. Please submit at the same time. 5, 4.
1 second, you forgot the checkbox on top.
Okay, you are right. So we will count again. Actually, it's good to show that this is working. This is part of the reason that we are using our application, because this way we are flexible to confirm security. Before this, we use Microsoft Form, and there are no options there that we like. So if this will work, we will do all the registration using our application. Again, I will count and then please submit everyone at the same time. Make sure that you mark everything that you need. I'm starting in 5, 4, 3, 2, 1. Please click submit. Okay, if you see this screen, probably it works. Check your email. With your email, you should get the second part. Let me check my email. And all you need to do at the second part is to click the link that you got. Okay, I got the email, so it worked for me. I hope that it worked for everyone. If it did not work for you, please tell me. Tell me now in the chat. This is why we are testing it. If it works, so you just need to click the link, and this will confirm that the email is correct. Email is confirmed and everything is okay. Torsten, have you done it? Can we continue?
Yeah. I already confirmed that everything works.
Okay. So as you can see, we also have a security. So we are using a dynamic data masking. So even in theory, if someone can execute direct link, so it's not matter. The email are not showing, the confirm will not see. Let's see what we have from today. Execute. Oh, awesome. I see a lot of people participate. Thanks a lot for everyone. I see that several of you activate, meaning you click the link. Several did not yet, but it's working. Thanks a lot for the test. Let's continue our meeting for today. Okay, so please feel free to use the chat during the meeting for questions and discussion as well. Remember, this is a user group. We are a bit flexible. It's not a conference, so you can also respond to each other. More than this, you are also welcome to use reaction. I love it. It doesn't interfere with the course of the meeting. If you hear something that you love, like, or you just want to clap hands virtually, then feel free to do so. I'm telling you once again, I love it a lot. It's a great feature. You are more than welcome to contact any of the community board if you have any suggestion or question. Jen Joseph is here with us in the chat as well. You can see him. He is the founder of the community and co-admin. Anna Weekly is the second co-admin. My name is Ronen Arieli. I'm from Israel, working as a senior consultant in the field of data platform and architecture of enterprise level system. I'm the third co-admin of the data-driven community, and I will be hosting the session today. Our speaker for today is Torsten Strauss. I hope that I pronounce it correctly. Torsten is a Microsoft MVP and data platform senior consultant, but the most important, he is well familiar with the Future Data-Driven Summit since he spoke last year. So really thanks for last year. It was a great session, I remember it. And I have the recording, which we didn't release. I will release in the next few days. There was a very big reason why I couldn't release anything 1 week after the summit. And I hope to see you this year as well. The call for speakers is almost closed. So I hope that you already submitted. If not, we are waiting. We loved the session last year. With this, please share your screen and take control. You can add some more words about yourself.
Yeah, for sure. Thank you. Let me share my screen. Can you confirm that you can see PowerPoint?
Yeah, we can see
okay,
PowerPoint.
Cool. Yeah, I just want to introduce myself. So, yeah, my name is Torsten Strauss. So the pronunciation wasn't bad. Yeah, it's very close. So I think the most important one is the email address. So whenever you have any questions with regards to performance tuning in Azure SQL, Azure VM, Azure Managed Instance, Azure SQL Database, or on-premise, feel free to reach out to me. I cannot promise for sure to answer all your questions. But if these are just small questions, I will definitely try to answer in time. That's me. You can see I'm working for different companies, for BP, for the Sarpedon Quality Lab, and for my own company, which is InsideSQLServer.com. That's all. Okay. So let me close this one. I will go. Okay, sorry. You can see that at least everything, and this is the email, by the way, which was sent by the registration process. So for me, at least, it is working. Again, thank you very much for having me another time here in your meetup group. Really appreciate that I was invited another time. Again, so as Ronan already mentioned, it is a user community. So I'm pretty sure there is a lot of effort to organize all these kind of meetup events on a so frequent base. So really want to thank the organizers for doing so, because I'm pretty sure it's a huge amount of work. So yeah, thanks for doing so and continue the great work. That's really appreciated. Okay, cool. What I want to do is this time, it is not a very deep dive, because I was thinking of just 1 hour time, and just want to give you some examples about I want to give you some real examples of slow running queries and a solution to make the query faster. So we will start simple. Later on, maybe it's getting a little bit more complicated. So what I want to do is I will show you the query which is running slow, and I will ask you, what do you think is the best solution to make it faster? So that means I will give you some time to think about it, and if you think you have a very great solution in mind, just come out of mute and just tell me what you think is the best solution. Otherwise, for sure, I will show you the solution, at least the solution which I have in place. So feel free to give me some advice when you think you can do it better, because I'm keen on learning. So what I want to do is, not pass only, sorry. I will use the AdventureWorks 2017. It's almost the same as 2022. Currently, believe me, I tested the queries on SQL database, on Managed Instance, on Azure VM, but because for the stability, I would say, I decided to demonstrate the session on my local machine, which is a laptop which I have in front of me. So just to make sure that because of bad connections or whatever, it is working. Again, believe me, everything you will see you can do in all, let's say, Azure SQL flavors. So let's give it a try. So first of all, when it comes to performance tuning, I think the most important one is to understand the statistics. So we have two statistics, I/O and time. Time will give you the elapsed time and the CPU time and I/Os. So to be honest, when I concentrate on performance tuning, I'm not very interested in the elapsed time. I'm more interested in CPU time and the logical reads. I will tell you why, because the elapsed time is nothing else than the time the user has to wait for the completion of the query. But the problem is that sometimes we see that another query is the reason that this query is running slow. That means the elapsed time is, I don't know, maybe 2 minutes, 3 minutes, just an example. But when you execute the same query later, you will see it immediately produce a result. The reason is that sometimes the overall workload, sometimes you have a locking situation or whatever. So that means sometimes you think it is worth to tune a query, but it isn't, because the reason why this query is running slow is because another query is currently running on the server, which have a big impact on this query. So therefore, as mentioned, the elapsed time is not very interested because, or not, I'm not very interested in the elapsed time. The CPU time is much more, I would say, reliable, and the CPU time or the elapsed time minus CPU time is the wait time. And therefore, you understand already, wait time is something the query has to wait so that a specific resource becomes available. So we have more than 1,300 different situations why SQL Server can wait. And again, sometimes the problem about a slow running query is another query, the workload, the setting of the entire database or whatever. So that is why I usually concentrate on the logical IOs, because then I get a feeling about the impact on the storage engine, which is still the slowest operation within SQL. So I have a good understanding about the impact, and the CPU time, not the elapsed time. I don't care. So there's another trace flag. I know that the trace flag trace on, or the other way around. This trace flag, first of all, will visualize residual predicates within a table, within an index scan, for example. So DBCC trace flags are not supported in Azure SQL Database yet, which I really find very bad. I understand the reason, but that is the only difference when you execute the code later on in your environment. The DBCC trace on will not work in SQL Database, but in all other SQL, let's say SQL managed instance and SQL VM. Yeah. So here I will enable the trace flag just to give you a better understanding about the execution plan later on. So okay, that is the, I would say, the setup. So what I should mention as well is that the example, the code which I will execute, will be executed in SQL Server 2022, so the latest version. Pretty sure even the latest update. Yeah. So and that's it. It's a very small machine in front of me. I think I know that I have just one CPU with 8 cores, and I think SQL Server has something like 10 gigabytes memory available. So yeah, very, very small. But anyway, hardware doesn't scale. That doesn't mean when I do the same exercise on an Azure Managed Instance or whatever, where I have much more power, maybe if I have 10 times more power from a resource perspective, this really doesn't mean that queries are running 10 times faster, because hardware doesn't scale. You know? Okay, so first of all, what I want to say is, what I want to do is, I have a query here, or sorry, a table here, which is called sales order detail medium, which is something like a Cartesian product between the sales order detail and the sales order detail. And I decided to stop after producing 1 billion rows, as you can see. So I wouldn't say a very big table, because nowadays we have a lot of records in tables, even in OLTP systems, which is perfectly fine. So I think we have something where performance tuning really matters, because what you need to understand is, when you have a table with just a few rows or just a few pages, because this is the smallest unit where SQL Server can save records, and the smallest unit of reading, or this is the smallest unit of reading and writing within SQL Server. Usually you don't need to worry about performance tuning. The problem is that databases always start small and it's growing over time. So therefore, we need to think about what will happen in future. That means we need to simulate a workload. We need to simulate, or we need to sheet SQL Server to get to sheet SQL Server to say we have more than, I don't know, 10 rows in a table, which we can do with DBCC update statistics, for example, to see how the execution plan behaves depending on data, on the amount of data. So that is something what you need to consider. Whenever you do performance tuning, you should already consider the data growth which you expect in the near future. So we have a table here with, as I already mentioned, with 1 billion rows. So I think it is a good candidate for performance tuning and to see whether we can do it better, right? So we have, or not me, SQL Server has some indexes, as you can see, some non-clustered indexes on top of the table. So the naming convention, you will see it over and over. Therefore, give me a minute to explain the naming convention. NCL is non-clustered, and then we have the name of the table, and then we have the column name, which is the index key. And then when we have an included index, then you can see which columns are included in the leaf. So therefore, you already understand that this index, and that is the index which we want to concentrate on, is an index, a non-clustered index, non-unique, on sales order detail medium, on the carrier tracking number, which also includes the order quantity. That is what you can see here. So this is the definition of the index, right? So that means we have a table with 1 billion rows. We have an index on carrier tracking number, which includes the order quantity in the leaf. Perfect. And it has data compression on. That's it. Okay, what I want to do is I want to first of all raise the checkpoint process, and afterwards I will drop all clean buffers, because now every page which we have in our buffer is clean. We don't have any dirty pages after a checkpoint process anymore, and I completely flush the buffer cache. So because when this is nothing you should do in production for sure, but when you want to compare different scenarios and you have to start from scratch, because again, you need to consider the physical IOs, which is still the slowest operation within SQL Server. And therefore, when you have a warm cache, or you start with a cold cache, and later on you have a warm cache, and you run the second query and you do some changes in between, that is very likely that the second query is faster because the physical IO is not even required anymore. So therefore, you have to make sure that the setting is the same, right? When you do performance tuning. And again, that is something you don't want to do in production, because now the code is completely, the cache is completely cold. So what I want to do is I want to give you an example of a very, very, very simple query. So it is running, as you can see, and it will take a minute, not a minute, 20 seconds. It depends on my, 1 second, let me try to do it a little bit faster. What I want to do is I want to, yes,
sometimes
at least
sometimes while we have a meeting, it's slower because we have Teams and everything. This is something that you need to take into consideration.
That means we have a small delay? Is this what you were saying?
No, I'm saying that because your machine, Teams and everything around it, it can create logs that usually you don't have.
Yeah, you're right.
Just take into consideration, usually when you speak in live, it might have a bit longer time.
Yeah, not even a bit longer. You can see the difference now, because I wonder why the query doesn't come to an end. It's already running for a minute, which I don't expect. But anyway, you can see that the query is running slow. What I want to do is, because I don't know why it is running that long, I think it is Teams, because Teams is using a lot of resources, I will stop the query and just want to display the execution plan, because we already understand that even after 1 hour and 21 seconds, the query wasn't executed, right? So let me go into the execution plan, into the one which is created before SQL Server will even execute the query, because SQL Server needs to have an instruction of how to execute the query. And I want to say zoom to fit, which should be big enough for every one of us. So now let's consider, or let's try to figure out what is wrong here. So you can see we have an index, right? An index on order quantity, on carrier tracking number, which includes order quantity. So in the query tries or aggregates the order quantity and is looking for a specific carrier tracking number. And okay, I can see the reason now, because I have option decided to do this with an option maxstop1, which means it is running not in a parallel way. I think that is the change I made. Therefore, we are running more than 80 seconds as I did last time. Anyway, it's running slow. The problem is, usually we expect to see an index seek, right? An index seek with a forward scan. That means SQL Server starts to go to the balance tree. An index is created as a balance tree. It will go to the root. It will go to the intermediate level. Depending on the index steps, it will go maybe to another intermediate level, and then it will stop on the leaf. And it will look for the carrier tracking number, and very likely, we know it, or I know it already, we have more than one carrier tracking number in the leaf. SQL Server will start to scan forward by using the so-called doubly linked chain, which is a chain between the pages in a sorted order. That means SQL Server will start with the very first appearance of the carrier tracking number within the leaf in the page, and it will scan forward until the next carrier tracking number is greater than the value which we are currently looking for. That is how it works. This is nothing, I would say, special. This is how an index works. The problem now is, why the hell it takes ages, even though I have a supportive index, right? So we can see we have an index scan instead of an index seek. That means you can see the estimated number of rows is it's a billion rows. So usually we expect to see less, because this is not just a unique carrier tracking number. We have just a few of them. It's a very selective query. So what is the reason? And this is what happened a month ago. The problem is the following. Just think about it. Maybe I will give you a moment to think about what is going wrong here. You don't need to give me an answer. I'm pretty sure some of you or most of you will get an idea why this happens. But to figure out and to spot this in production is a complete different story. Because, I mean, when you see the execution plan, when you see the index, when you see the predicate, maybe you already have a guess why it is running slow. So for sure, and usually you expect, you get some feedback from the user, it's slow, then you go into the query store to figure out what is going wrong. You will see the plan. Okay, now the problem is the following. You have a supportive index, but for whatever reason, the driver, and in this case, it was Databricks, which was trying to read data from the big table here. For sure, it's a complete different database, but the design, the schema, and the index was exactly the same. The problem is that the driver by default sent strings in a Unicode format. You can see it. This is, I mean, I simulated the same by adding an N, which is a Unicode. The carrier tracking number in our example is not a data type of a Unicode. Instead, it is a varchar. And now you need to know that we have a so-called data type precedence. That means you cannot look for a Unicode within a non-Unicode balance tree, but the other way around, right? If the carrier tracking number would be a Unicode column and we are looking for a non-Unicode string, the index could be used by SQL Server, but not this way around because of the data type precedence. So that is something which you need to understand. You may need to make sure that sometimes, or not sometimes, you should consider selecting the right data type in the predicate. I mean, how can we fix this? Okay, so we fix it because we were able to change the driver default settings. But usually when you have a stored procedure and you expect a parameter which is in Unicode or not a Unicode or whatever, we already have a guarantee that the right data type is used within the predicate, right? So this is an ad hoc query, and Databricks and all these entity frameworks or whatever, even the entity framework which we had in place, by the way, sent characters as a Unicode. So that's odd. I mean, no index will work. For sure, you can go ahead and change all the columns and make it a Unicode and rebuild your indexes. But why should I? Because, I mean, when we have just English or German, I don't know, language in the table, why should I use Unicode, right? So let me flush the buffer another time, and I can see my battery is draining. Maybe I need to find I have a socket here. No worries. I will flush it again, and this time I simulate the same or execute the same query just with a small change. This is not Unicode anymore. And hopefully this time it is there. It took less than a second because it takes some time to visualize the execution plan, zoom to fit. And this time you can see an index seek, right? So in the expectation, the number of expected records is definitely less than 1 million. The statistics are not very precise, as you can see, because actual is definitely less than the actual. Actual is less than the estimated. But anyway, I mean, we have a response time which is now down from, I don't know, maybe half a minute, right, down to is less than a second. The reason is for sure that we are just reading 7,496 rows, which we can see in the statistics as well. Sometimes it's a little bit less, sometimes a little bit more. It depends on the last index rebuild, but you can see it's definitely a change because before I stopped the query, but before we read 230,000 pages, and each page has a size of 8 kilobyte. And you can see that this does not scale, right? So that's this. Again, we start simple, but sometimes people don't even know that we have a data type precedence in place, which sometimes has a big impact on the execution plan, so an index cannot be used. So feel free to come off mute when you have any question. Otherwise, I will continue. So there's another query which is called sales order detail big, which is even bigger than the one before. Sorry, is that a question?
Torsten?
Yeah.
No, just to clarify, I'm following the chat, and it's a good opportunity to remind everyone, please use the chat for questions.
Yeah.
And if there is a need for speak, which is very rare, so please use the reaction and put your hand up, but use the chat freely.
Yeah, I'm not monitoring the chat, but if there's any question and you're maybe too shy or whatever to ask, come off mute. Yeah, just put the question into the chat. Yes, exactly.
Don't
cool.
worry.
Okay, cool. Okay, so the sales order detail big table even have more data or records than before. You can see we have 500 billion. It's less, right? 500 million rows is less than 1 billion rows, but anyway, it's still a big table, right? Okay, so what I want to do is with this table, first of all, I will flush the buffer another time, and I will do something like this. So we have the table sales order detail big in the middle here. We have sales order header. That is the schema, the ER model of our AdventureWorks database. So nothing special, just replace the order detail with order detail big to have more records, because AdventureWorks just have a few records. It's okay, but when it comes to performance tuning, again, you need to have big data, right? Then we have a product table here. So this is called a star schema. When you now visualize a table in the ER model, you would see that we have a fact table in between, which is surrounded by dimensions. Yeah, it is the idea of the AdventureWorks database, and we have an AdventureWorks data warehouse database, which is produced by the AdventureWorks 2017 database. So that is the star schema. We make it very simple, right? So what we are trying to do is we want to execute this query. And I hope this time it doesn't take ages, because I don't have a hint of using just one core, which I had before. So give it I don't know, maybe 60 seconds. I will do the same in another window. Just first of all, want to display the execution plan because we can see already the problem, right? Because I don't want to keep you waiting for a minute. Zoom to fit. So that is the execution plan, which isn't very complicated, but you can see, first of all, it is a plan which is running in parallel, it is a parallel plan. The query is running in parallel. So the reason is that because of the estimated subtree cost is 2,500. We don't have a unit for this because this is nothing else than CPU, memory, and I/O, based on the cardinality estimation. So that is why we will never ever see an actual subtree cost. There is nothing like an actual subtree cost. So we will see it in the end that even the estimated subtree cost can be completely wrong. So don't rely on subtree costs. because this is an estimation based on the cardinality estimation, and this value goes into the cache plan. That means the next time you execute the same plan with different parameters, but the plan is reused, the estimated subtree cost is definitely wrong. It can only be wrong. Okay, so the plan is the query is running in parallel. Okay, let's see. It took 35 seconds. So the first question you need to answer yourself is, or you need to this is the question for you. Is this already fast enough? So when you say, okay, 35 seconds is not bad, so user can wait maybe roughly half a minute to get something like this, because this is a query which is not very frequently executed on the server. That's fine. Stop here, right? So maybe you should worry about the CPUs and memory which is allocated, because we have a HashMate join. There's a memory grant on top, which we don't see in this plan because this is the estimation, but we see it here. So the memory grant is 68 megabyte. If you say that's okay, because I don't have a very high contention on the SQL Server, stop. Yeah, so that's perfectly fine. But let's try to do it better. So what can we do in order to improve? I mean, this is a typical data warehouse query, and everyone which has some experience in SQL Server is thinking, okay, when I have a data warehouse query, why not using column store indexes? So that means I will flush the buffer another time, and this time I will execute the same query another time, but the difference is that I have a copy of the same table, 500 million rows, but it is organized by a clustered column store index. That is the only change, but it is a big change. When I execute the same query another time, it will take maybe roughly 5 seconds, even less, 3 seconds. When I execute this a second time, it is already in cache. So here you can see that it doesn't make sense to do it query tuning when you have a warm cache, because you need to understand the impact on the disk as well. But we are down to a second, which is completely different than 35 seconds. The reason is that now SQL Server is able to use a column store index, which we can see, which we can see here in the execution. Come on, zoom to fit. Zoom to it. Here, which we can see here. And the way a column store index is the architecture of a column store index is completely different than a row store index, right? We have segments, we have row groups, we have very high compression, we have dictionaries, we have a lot of different things in place to make data warehouse queries fast, especially when you want to group by when you want to aggregate data and you're not looking for a specific value, because this is something which is slow within a column store index. So an OLTP query actually or usually looks for a specific record like a customer number or whatever. Here we are aggregating data, all the data which we have on the table. Maybe there's a time period. Maybe this is something which we have in place here. Yes, we have something like this, but that's all, right? When you have a pattern like this or a requirement like this, column store index is definitely the better choice. You can see the estimated execution mode, which is a batch mode, which is different than a row mode, which is usually the case when you have an OLTP query and no column store index in place, right? You can imagine that a batch works faster than a row mode, because row mode means this operator requires one row from, let's go with this one. The compute scalar requires or asks for one row from the index seek and will pass it over. So row by row, and you can already imagine this is slow. Now we have a batch. That means this operator will ask the column store index scan to give me a batch. A batch is a number of rows. So therefore it's much faster, because you can pass more rows within one batch across the execution pipeline, right? I don't want to go into detail about column store index. That is not the aim of the session, right? I just want to give you some examples to give you an understanding what you can do when you have something like a requirement like this and your query is running slow. I think, to be honest, just give me 10 seconds. I need to go to the socket, and the socket which I have here on my table isn't working. So 1 second. I'm still here. 1 second. Just need to have some power. Here we go. That's all. Okie dokie. Let's go down. Next thing is the cardinality estimator. So the problem is that with every single SQL Server version since, I think, 2014 or maybe 2016, I didn't remember, I think it was 2014, Microsoft decided to implement a new cardinality estimator with every single new version. That means we have a different cardinality estimator in 2022. I think it is 150 or 160. I didn't remember anymore because I still don't understand why we cannot call it 2022, because then everyone knows, okay, cool, we have a 2022 cardinality estimator because we have a 2022 database. Yeah, but okay, it's like it is. So what I want to say is the cardinality estimator is there to for the so-called best guess. That means when you have when you combine predicates and for example, when you combine predicates with an or statement, not an and, you cannot even create an index which is supportive, because you cannot say I want to have an index on column 1 or column 2. That nothing which you can create. You cannot create a composite statistic for this case. You cannot say I want to have a statistic for column 1 or column 2. That is nothing which will work, because you have to combine the rows, the index keys or the statistic keys. So therefore, SQL Server needs to have an algorithm in the background to combine the statistics and come back with a so-called best guess. So the best guess will tell SQL Server how many rows very likely will go through the execution pipeline. We can see it here, for example, the estimated number of rows, everything which is with regards to estimated number of rows for all executions to be read to, as you can see it in the middle of the pop-up window. I cannot move the mouse because otherwise the pop-up window will disappear. Okay, it is like it is, but I'm pretty sure you can see the portion within the pop-up window. So the estimation is based on the cardinality estimator when you have a specific combination of where predicate in the predicate. Let's say it this way. Again, I don't want to go into depth, but the assumption is from Microsoft with the new cardinality estimator that one column is more dependent on another column. Think about in a car manufacturer. You have, I don't know, Audi, VW, and so forth, and you have a model name like Q1, like I don't know any model from VW, to be honest. But you can see that there is a high dependency between both columns, and this is something which is taking more and more into consideration with every single cardinality estimator, apart from other changes. So that means we need to rely on the reliability of the cardinality estimator, because the query does the same. So we have an index here on sales order detail medium on column 1, right? So, and I will enable the query store because I will show you what happens in the query store. And I will clear the query store before I will go ahead, because otherwise we will see a lot of queries and it is very hard to find the right query. That is the only reason. Usually you shouldn't do this in production for sure as well. We will flush, I will do call the checkpoint process, and I will flush. So we have a cold cache. So this time, what you can see here is a very, very, very easy query, and I will execute the query in the meanwhile. So we are asking SQL Server to give me all the records. Let me go to another session because I want to show you the table. Okay, here we go. Sorry. This is a table. And you can see that we have one additional column which I added, which is column 1, which is always 1. That means when I go to the statistics of the table within AdventureWorks database, we should see statistics on column 1. Let's go to AdventureWorks 2017. Let's go to the table, sales order detail medium. Let's go down. It's a little bit slow because it's still executing. It's funny. So, but anyway, it is like it is. So sales order detail medium, that is 1. So here we have the column 1, which is of tiny int, perfect, because we have only we have only the value 1 within the column. let's go to the statistics, and we can see from a statistic name that we have one which is for, is that one? Which is for the column, for column 1. That means when you leave the default settings on, SQL Server automatically creates statistics for columns which are used in a predicate, right? And we can see the details of the statistics. And I don't want to go into statistics. We can do it, but nothing which I can cover in an hour. The most important one is the all density. The all density will tell me that we have just unique records, because it is nothing else than the number of unique records divided by the number of rows within the table. So that means when I have not me, SQL Server has 1, we have only one unique record. So the unique record, unique value is 1, because we can see there's a range high key. That is something which is called the histogram. So that means we have not more than 200 steps, but you can see we have only one step because we have only one unique record, or unique value. Record is wrong. Unique value within all records. So that means from that perspective, SQL Server should know, okay, I have a density of 1. I have just 1. So that means when I now ask SQL Server to give me the result set of this query, the expectation is it's still executing. Oh, this is crazy. Okay, I will stop. Okay, I will stop after 2.5. I don't know why it is so super slow. It is really Teams, because usually it should be done within 45 seconds. But now you can see it is even taking 2.5 minutes, yeah, which is crazy. Because what is your expectation? When I ask SQL Server for something like this, give me all the records where column 1 is either 0 or 4.
Torsten?
Yes.
Let's close the camera if you are using a remote data, because the camera take internet
Okay,
speed.
Yeah. Okay, no worries. I mean, you can see that the query is horrible slow. Okay, if you have some overhead, but last time where I haven't had any overhead, the query took 45 seconds. So again, let's ask the same question. I asked SQL Server to give me all the rows where column 1 is either 0 or 4. What should be the answer? Nothing. SQL Server will never ever estimate 0 rows. It will always estimate 1 rows when we don't have any kind of contradiction, because then we have an assert operator. Therefore, we will see some kind of an operation, execution plan for sure, but it should be finished within less than a second. It took more than 2 minutes and 40 seconds, because I don't know how long it would take to execute the query. Last time it took 45 seconds. The problem is, this is a bug. It is a bug, really. It is reported to Microsoft, and it is there since 2019. I don't know the reason why it is still there. I understand that maybe in other scenarios there is a benefit of the new cardinality estimator. I'm pretty sure it is, yeah, because otherwise Microsoft wouldn't introduce a new cardinality estimator. And when people complain, usually they are very fast on fixing these kind of bug, or in this case, the cardinality estimator within the next CU, yeah. But for reasons I don't understand, and this is, I don't want to blame Microsoft here. I don't understand this. Yeah, okay, but it is still there. Let me go to SQL Server 12. In SQL Server 12, we had a complete different cardinality estimator, which is of version 7T. So let me erase the checkpoint and the dbcc drop clean buffers. So my cache is empty. And this time I will execute the query another time, and hopefully it will take, yeah, okay. This is even working without the camera, even with the camera on. So we can see that this time we have a very simple execution plan. We can see the estimation is 1. Before, when we go into the execution plan, you remember that I decided to cancel the query. That is the reason why we couldn't see the execution plan, but the estimation was something about give me all the rows from the table. I think we can even do it, because I just need to display the No, I cannot, because otherwise I need to change the compatibility level another time. But believe me, when I execute the query and it comes to the end, we should see that the estimation is all the records from the row. That means this query will not scale. The more records we have, the longer it will take. When we do it right, or SQL do it right in this case, with a better cardinality estimator, it is immediately here. So you can see how it works, right? We are just reading 8 logical reads, which is next to nothing, right? So the problem is, when I now change the compatibility level of a database, I'm changing the compatibility level for the database, and therefore I change all the features for the database. That means my database is now running in SQL Server 2012. So therefore, I'm missing a lot of very, very beneficial features. That is not a very good idea, right? Because you can see I can fix a problem like this when I know how to fix it. Going back to, I would say, a former SQL Server version. And that's it. By the way, the first guy who told me about the bug was Milos. Milos is another MVP. Just want to give him the credits for that. Yeah, so it's definitely fine. Okay, but because he told me that this is a bug, like you can see, this is definitely something which isn't expected. I decided to do the following. Let me go to the query store. Over top here. So that is one, which has, that is the squares, because I decided to cancel the query, but now we can see the execution plan, which is, one second, give me all the rows, right? 10 billion, 10, 1 billion, I didn't remember. It's 1 billion, it's a little bit hard to read because I don't have dots here, but I think it was 1 billion rows. Give me all 1 billion rows, filter, sort, because there was an order by, do it in parallelism, and finally output nothing. That is crazy, isn't it? The second execution with the compatibility level of SQL Server 12, and we can now compare this one. Completely has a different execution plan. You can see the cardinality estimator change from 160, which is 2020, to 70, which is 12, and before, I guess. So when you know that you have a problem by the cardinality estimator, and again, most queries are running faster because of the changes of the cardinality estimator in newer versions, but some of them are running slower. And when you're on the, let's say, on the bad side, then maybe a few queries in your environment are running slower after your migration. So that means when you migrate from one database level, so compatibility level or version, which is from 19 to 2020, for example, you need to consider these problems and you need to spot them and find ways to resolve them. So that means from a migration perspective, when you migrate, you should migrate the instance, the server, but you should restore the database and keep the compatibility level of the former version for a while, do some, I don't know, some workload, yeah? And after a while, change the compatibility level to the new version. So the other way around as I'm currently presenting, but it works like in both directions. Usually you do it this way because this is a migration. This is my example, just to showing the bug, right? And after a while, you can compare the plans. And now you think, okay, this is nothing you can do manually, right? And I was thinking the same. So let me go to, I just need to close a few windows. Yes, okay. So it took me a while, but what you can do is you can ask Query Store for a lot of information. Let me scroll down because this is a very, very long, very big query here. I will execute the query and you will see the result, which is more interested than the query itself. Still, okay, here we go. Oops, that was a little bit too fast. Here we go. Yeah, here we go. So when I execute this query, you will see that we get a result which will show you the difference between the queries which were running in compatibility level SQL Server 12 and SQL Server 2022. So you can see, and it also works from 16 to whatever, it works from 2019 to 2022 or whatever, yeah, even for upcoming versions. So that means we now can spot the queries with a high difference between, or in terms of the duration. We can see, okay, we have the same query with 2 execution plans. That is the first one. I will close this one because otherwise I'm a little bit lost. We have another one, that one, cool. And we know the reason already, because this is the reason why we run the query. And now we can decide what is the best cardinality estimator for this query. So let me go down. So what we can do now is we can go back to SQL Server 16. So this is the migration, right? Now you decide, okay, let's give it a try. And we can now say, I want either set the legacy cardinality estimator for the database, but apart from this, I'm still using the new features, right? Because I'm not changing the compatibility level of the database, but just tell SQL Server use the cardinality estimator. That makes sense when the majority of your queries are running slower with the new cardinality estimator. Otherwise, it doesn't. Sorry, I haven't executed this one. At least the cardinality estimator is still the new one, because otherwise it would be there. So you can see, that means the query plan is exactly the same, right? Because it is just the query, not just all queries are running with the cardinality estimator, with the old one. Sometimes a good idea, sometimes it's bad, because again, it will be applied to all queries, which I don't think is a very good idea, because again, cardinality estimator is doing a great job for for the majority of the query, but not for all of them. But now you know which queries are running slow. That means we can go to the code and say option use hint force legacy cardinality estimator just for the query. We are now on the new latest SQL Server version, latest compatibility level, cardinality estimator, legacy cardinality estimator is off, cool. And now let's go and execute the query another time. It works because of the hint. But before hinting the query, you need to figure out and spot the queries, which will definitely benefit from the legacy cardinality estimator. Okay.
Hey, Torsten,
yeah.
we have a small request in the chat to share the query. I'm not sure if it came from Conda, so maybe you can use your microphone to explain. I'm not sure if it means to share it now in order to understand what you have done, or in order to use it after the meeting. So
let's do it. Yeah, let's do it after the meeting, okay? So I will stay in the line, and I will definitely answer the question. Okay, is this fine?
Okay, so,
I hope so.
After the meeting, we will share everything. Just pass me all the information.
Yep.
I assume that this is the request.
Yeah, okay, yeah, for sure. Yeah, I will do. Okay, cool. Okay, so yeah, another query. Yes. Okay, very common approach and nothing new. Really, this is not new. The bug is new, okay, but this isn't new. And the column store index is not new, and the data type precedence isn't new. It's there for a while, right? In this example, use also techniques which are there for a while and even available in standard edition, right? But anyway, I mean, why should we go with new features when we have to learn the old features, right? So let's give it a try and say, I want to give my SQL Server 10 GB of memory. I think it was already the case, but I just want to make sure that my example is always doing the same, so it is repeatable, and therefore I can rely on the execution plan because the hardware settings are the same. Okay, so we have a sales order detail medium table. We know it already. We have 1 billion row, yeah, so 1 billion, not 10 billion. That's fine. And now what I want to do is a very common approach. A vendor gave me a call and they had a problem. Coming back to a real life example, and all of them were real life examples, by the way. The vendor told me, okay, I need to delete old records from my table older than, I didn't read 5 years. Yeah. So they had a lot of records in the table. And the table you can see here, which I use, sales order detail mediums, for sure, their table were named differently. But you can see they had a data range they want to get rid of, because otherwise the server really, it was a lot, it was a lot of data. So, and they decided to get rid of data older than 5 years. Pretty likely and a very common requirement, right? After a while, you want to get rid of data. And to want to get rid of data, it means you want to delete the records in this case. So there is in order to simulate the example, what I decided not to delete years, instead I want to delete 2 days, but the requirement is still the same. Get rid of a specific portion of data within your table, because you want to save storage, you want to save database, index maintenance, for example, you want to save time with regards to DBCC, CheckDB, and all these kind of problems, which, or not problems, but the overhead which comes into play when the table is growing and you don't need the data anymore. Yeah, you're wasting resources, right? So we can see that we have something like 26 billion of rows out of 1 billion of rows. So, okay, that's fine. Even if we have just one record, I don't care. I want to get rid of a few records. Okay, let me do this. I want to reset the weight statistics. And what I want to do is I want to run this query. Delete from sales order detail medium where last updated is these 2 days. Okay. What I want to try, there's no guarantee that it works. I will enable live execution. No, it will not work. Sometimes it works, sometimes it doesn't. Okay. Then I'll show you the estimated execution plan. Let me go here and say, okay, so you can see that, sorry, and zoom to fit. Cool. It's not, okay, I hope you can see. I mean, we don't need to go into detail. What you can see is that the table just have more than just one index, right? We have 1, 2, 3, 4, 5 indexes, right? And when we delete records, SQL Server for sure have to make sure that we are deleting the records, the 2 days within the table, which is a heap, I guess, if I remember correctly, and the 1, 2, 3, 5 or 6 additional indexes. That means even though we have just one index, a clustered index or whatever, it takes forever. But because we have a factor of 5 or 6, it even takes much, much longer, right? So that means I decided to quit or to cancel the query after 1 day. The vendor had a problem. They decided to quit, to cancel the query after a week. The problem was that it was really funny. I don't want to blame a vendor, and I don't want to name the vendor, but he forgot to enable accelerated database recovery at that point in time. So that means he had to wait another few days to roll back the entire transaction. The entire system was completely blocked. The table was blocked for sure. Yeah. So let's give it a try. What happens when I try to delete it and it takes forever? So let me go to another session. And what I'm trying to do is I want to read data which I'm currently not deleting. You can see it's greater than the last day which I'm going to delete. So let's do this. And we can see I'm blocked. I'm blocked because we have for sure, let me go to another query in another session. We can do it with, let's go with tran log. Yeah. So we can see we have a lot of pages which are locked by an update log. All right, and we have one intent exclusive log, I'm pretty sure on the object level, as well as a shared log somewhere waiting here. That is one which is waiting. That is the session which is trying to read from a table which is currently updated. Because the on-premise works with read committed with a read committed transaction isolation level, a shared log is not, or an exclusive log, do it the other way around, is not compatible with any other log and therefore not with a shared log. That means this query will block everything. No one was able to get data from that table because they tried to delete records. Strange. So let me roll back the query. First of all, I need to cancel. And now let's do it. I have accelerated database recovery in place, thankfully, because otherwise you have to wait. So this wasn't an explicit transaction. Anyway, so let's do the following. What can we do in order to do it right? I mean, we are just deleting records. It should be fast, but it isn't because of the amount of indexes. And for sure, SQL Server need to look up for the values which we are going to delete. What is the solution? We should partition tables. So that means whenever you start designing your ER model and you know that the table is growing over time and you have a meaningful partition key, which can be a composite key when you do it as a computed column, by the way, which is persisted, then go ahead. You can create 15,000 partitions per partition function. So let's do it. So first of all, let's try to understand. That is funny. Now the live execution plan is working. Okay, that is not what I want to see. So we can see, by the way, that the query which we are trying to read was completely blocked, and we can see it also in the weight statistics. So that is the reason why sometimes you see a very high LCK, so log _m _ intent shared log, because this one was blocked by just deleting records from the same table, even though other records as the records I want to read. So let's, okay, I don't need to execute this one because I know that we rolled back the transaction. So what you can do, and I know partition maintenance is something which is definitely more complicated. I created the stored procedure or code which does everything for me fully automated, depending on the data type. It detects the data type, it detects the interval, it creates new partitions, it will create new file groups. It does everything for me. It took me 2 weeks to develop, but it works. When you have something like this in place, all you need to do is you need to create a partition function. You define the values. You can see on a daily base. Usually you have something on a monthly. No, I don't want to say usually, but okay, maybe you have it on a monthly base, on a yearly base or whatever. Then you create a partition scheme and you assign the partitions, the logical partitions, to the physical file, to the logical file group, in the end to the physical file. Here you can see all goes to primary. And then you create the same table another time. That means I have a copy of the table. That is something which is a little bit, when you do it in production, you have to think about the right strategy because you don't want to have a downtime for a few days just to copy data. There are strategies to avoid this, but for the example, for this purpose, I don't care. So in the end, I created exactly the same indexes, but you have to make sure that the indexes are aligned. That means the partition key have to be part of the index, which isn't a very big problem because you can put it into the end. The only problem is when you have a unique index, then you are in trouble. Then you need to create a so-called trigger, right? But anyway, so in the end, you have something like this. Can see that we have, this is our new table. It's exactly the same table as before, same amount of data, but this time it is partitioned. And you can see that we have an uneven distribution, but I don't care. So we can see that we have different partitions with different values. So that means there's a guarantee that every single value goes through the right partition by the partition function and the partition scheme in the end. So now I can ask SQL Server for the partitions where we expect to see the 7th of July and the 8th of July. And yeah, it's the 7th and the 8th a partition, or the 7th and the 8th partition. And what I can do now is very easy. I can do something like this. I truncate a partition. A truncate is a minimal locked operation. SQL Server just need to deallocate the extents, which belongs to the table within the GUM, within the IRM page, and I'm done. So that means all I need to do is something like this. I'm done within less than a second. For the same effort, which took ages. So, and that is something which you need to consider. So my big advice is, when you know already that your table is growing over time and you don't want to save the records forever and you have a meaningful partition key, why not starting with partition? You even have advantages or benefits with regards to partition elimination when it comes to query optimization. Or think about you always add data in the very end, right? So like invoices or whatever. I don't want to rebuild my index, my statistics for the entire and growing table. I just want to do it for the very last partition. That is something which you can do when you have partition in place, right? So
not the time, Torsten. We are flexible a bit, but
no, that's okay. That's okay. I don't want to go further because the very next one is about thread pool starvation, and then the very next one is about pagelet contention, and the new option which you have optimized for sequential key and also in memory OLTP. These are more complicated examples, right? And I don't want to start because I'm pretty sure I'm not able to finish. So therefore, I think it is much better to give you to give you room for your questions. Do you have questions?
Actually, we don't have any question at this time. There was a comment before. If you can present something fast in 2 minutes, it's great, because it was very useful session, like always. I think that people can actually take the information from the session and implement it just when they are coming to the office.
Yeah, I hope so. I hope so, yes. Yeah, cool. Maybe I have a chance to present the second part. Yeah, maybe in a I don't know, half or in next year time. Yeah. So okay, but again, it doesn't make sense to start with a new example of query tuning because of missing time. Okay, so is there maybe another question? 1 second. Thanks for yeah. Okay, I will share. Yeah, I will share. I need to think about.
I think that they are not relevant to the session.
Yeah. Okay. Cool. So nothing is left. No. Okay. Then I would say thank you very much for the invitation. Thank you very much for participation. Yeah, and I hope we will see at least on the big event. Yeah, where you registered in the very beginning of the session. Yeah, definitely advise to go there because we have a lot of very educated speakers and dedicated speakers. Yeah, I hope I will see you soon.
Thanks a lot. It was a great session, very useful. I want to thank everyone for the help at the beginning regarding our test. If someone did submit the form and did not get the email, then please inform me as soon as possible, because I assume that everything was working okay, and we will continue with this form. I see someone in the chat. Thanks a lot, guys. And to you.
1 second. I raised a hand to ask a question and didn't have a chance to ask.
Yeah, sure.
Yes, I noticed you're running Windows 11, which is notorious for its slowness. And I provided a link in the chat which explained what's happening. Windows 11 is by default encryption. So many people going because of it to Windows 10. Did you experience such problem? Because it's overall directly with the performance.
Okay, interesting.
I heard you complaining my computer is running slow. That could be the reason.
Yeah, maybe I will I'm currently, I have the article open. I will go through it. Maybe it will fix the problems, which I can see. Great. Thank you. Thank you for the link.
No problem. My pleasure.
I actually learned that everything that related to Windows 10 and 11, it's problem.
Yeah, you're right.
But this is my personal experience. The one thing that I most dislike is the update. That just okay, it's crazy. It's not related to our session. Thanks a lot for the info. It's it can be very useful to a lot of people, but don't use Windows 10 or 11 for server. Use Windows Server or use Linux. Personally, I recommend Ubuntu. We made a lot of performance tests with probably all the common operating system. This is my personal recommendation. Ubuntu bring the best performance for SQL Server. Yes, for Microsoft application, Ubuntu is better than Windows.
Okay, I don't want to comment this. It is like it is, yeah.
This is a personal comment, but after a very professional test that we have done, we're working with a database of over 100 terabytes. We needed to do a lot of tests before we decided several years when Linux was added as something that's supported, and we are all Unix people. My main client, so it was more natural to check if Linux fit, and this is our, again, it's specific case, but for us, we found out that Ubuntu is much better than all the rest of the operating system, compared to other Linux as well. We checked Red Hat, we checked Ubuntu was the best for us. Anyway, thanks a lot, Torsten. I hope to meet you again. It's not hope, I will meet you. I will not let you pass it. I want to see everyone at the Future Data Driven Summit, and we will meet all next week in our weekly meeting. So thanks a lot.
Thank you. Bye-bye.
Bye-bye.